we're asked to graph a piecewise defined function that represents this particular absolute value. So if we use the definition of the absolute value, we've got the absolute value of some value is equal to the following. It's equal to, and actually I'm going to put in here, instead of using x because that can be confusing, I'm just going to put in here a block. Okay, so the absolute value of this block is equal to the block itself. Okay, if that block is greater than or equal to 0. Okay, it's equal to the opposites of the block if that block is less than 0. That's the definition. So if we take this up here and we rewrite it, we've got the absolute value of x minus 3 is equal to x minus 3 if x minus 3 is greater than or equal to 0 and is equal to negative x minus 3 if x minus 3 is less than 0. Now, we usually write these backends, these definitions, these ideas in the domain a little bit different. So what we're going to do here is we're going to write this out. We're going to simplify it. So we have x minus 3. This is x is greater than or equal to 3. And this is going to be equal to negative x plus 3 when x is less than 3. So this is the absolute value of x minus 3. Now let's go ahead and graph that out. So let me grab a straight edge here and move this down just a little bit. First, you guys already know how if this is f of x and this is x, and we're looking at f of x equal to the absolute value of x minus 3, you guys already know that the absolute value of x is a v shape centered at the origin. And when we subtract 3 on the function before the absolute value has a chance to act, that moves it to the right by 3 units. So we're going to see 1, 2, 3. And so our function, let me go up like this, still looks exactly the same as what we would expect. Okay, so this is what we're going to expect to get. Now I'm going to show you that the piecewise defined function that I've got up here gives this exact graph out. So let's go ahead. This is from what we know. Okay, now let's go to this new piecewise defined function of absolute value. We see that we get the same thing. From the piecewise defined function, our cutoff value is 3. Like this. Okay, right there. And we have x minus 3 when x is greater than or equal to 3. So we're going to have x minus 3 on this side, and we're going to have negative x plus 3 on this side. Let me erase this, I don't want this in the way. So I'm using this function over here to get this graph, which is going to look exactly like this blue one over here. So let's make a little xy chart on both sides. So over here on this side, when x is 3, we would, right here, we would get out 0. When x is 2, because we're working to the left side, we get negative 2 plus 3, which is 1. When x is 1, we get negative 1 plus 3, which is 2. When x is 0, we get 3, so on and so forth. So start plotting these points. Okay, we're going to have 3, 0, open circle, because we're actually, hang on. Yeah, open circle because we're not including it right here. And then we've got positive 2 up 1, positive 1 up 2, then up 3. Let's redraw that in a little bit better. Okay, I don't think it's a lot better, but you get the idea. We'll just make the dots bigger. Okay, now what about the other side? Well, the other side, I'm gonna do the chart right here for it. When I plug in 3, I get 0. when I plug in 4, so 4, 5, 6. When I plug in 4, I get 1 out. When I plug in 5, I get 2 out. When I plug in 6, I get 3 out. So those guys at 3, 0, it's filled in. So that fills in our circle right there. At 4 over, I get 1 up. 5 over, I'm 2 up. 6 over, I'm 3 up. Notice that these graphs are completely identical. So what you learned before about graphing applies to this piecewise defined function over here with graphing.